Welcome to this session of Shadow the Scientist. My name is Jamika Marshall, and I'm very pleased to serve as the Shadow the Scientist Programs Manager. You all are in for a treat this morning as you have for your science host, Dr. J.D. Armstrong, who is the project scientist at the Faulkes Telescope North and the Maui Technology Education Outreach Specialist. Now, in this session, JD is going to be leading you through an introduction to observing with Las Cumbres Observatory. And we know that you have, and congratulations on being awarded some citizen science time for your project on Las Cumbres Observatory. So JD is going to be taking you through that observing process. Now, throughout this session, please put your questions in the chat for me. I will convey those questions to JD when there's some downtime in between when he's talking. So please don't hesitate to start putting questions in now, and I'll make sure that we get to him. Let those get to him. All right, I'm going to stop my screen share and let's go ahead and welcome again back to the stage, Dr. J.D. Armstrong, our science host for the evening. Welcome back, J.D. Oh, you're muted.
Okay, there. Now I'm unmuted. This is what it's going to be like. I will forget things all the time. Thank you for the introduction. As always, you're too kind. Wonderful to have everyone joining us today. And I mean, it's really kind of cool. This is, halfway around the world. And so I'm going to start my screen sharing here. And okay. So you should see my Las Cumbres observing portal. Is that correct?
That's correct.
Okay, good. And so what I thought we would do is we would go through an exoplanet observation in particular. Okay, that should cover just about anything that I can help you with as far as starting off. Well, okay, maybe not, but I think it's a good place to start off. So if you want to observe an exoplanet, first place you probably are going to want to go to is the NASA Exoplanet Archive. So that's right here. I also put together a little bit of a document that'll have a brief overview of what I'm doing here, what I'm doing tonight. So hopefully that'll be helpful.
I'll share that with them at the end of this session, JD. Thank you for the reminder.
Okay, great. And so we want to go to transit and ephemeris service. Now, when we're looking at exoplanet transits, I'm pretty sure that you all know that you have to observed at the right time. And so you need somewhere to predict when the events are. And this is a great place. They have huge list of planets, of exoplanet transits. And they'll just give them to you very quickly, easily. What I would suggest doing to begin with is start with custom start end dates. Unless you have a specific target in mind, if you have a specific target, you could come over here and click on single target. I'm going to go ahead and just go back to multiple targets. So I'm going to ask it for about a week's worth of predictions of exoplanet transits. And then that's all I really change in here. And then I go ahead and click predict events. Now this will take a minute or two to do. And you can go and do other things while it's doing it. And every now and then it'll come up with a web page. Oh, hey, this is still processing, so that you'll know that it's still processing. And then what you'll end up with is a table that you can download. And I usually go with the .csv table, which looks something like this. Okay, so here's our, this is still, we're still working on your request. And so, and I'll show you how to download this table. And then I've actually run this through a filtering program that will filter for the magnitudes and also the transit depth. So for the Las Cumbres observatories, if you're using the OM4 network, I suggest probably don't go fainter than maybe a magnitude of 15, and probably try to get transit depths that are at least 1%. So you can look at the transit depth here. There's calculated and measured. And so, and then I've run this through a program that filters for that already. So you probably will not see anything less than, well, it's a little, I go a little bit fainter, less than 1% transit depth. So these are in percentages. So I go ahead and filter that with a Python program. And I also had some other things, but we'll deal with that later. Okay, so this is what it looks like when it comes up. So it's nearly 35,000 events. That's quite a bit. But you can look at this and then you can go ahead and download the table. I usually use a comma separated variable format. Download the table. And then I've already downloaded one a couple days ago. So if I have it set so it'll automatically go into LibreOffice. And so if I double click that, and then I come down here and kind of look, I can see whether or not the columns are coming out correctly. In principle, maybe not. Okay, but I have it separated with commas and nothing else for this. And then that table should open up nice and neatly. I usually delete this because I don't need it. But I leave the titles because I, of course, need that. Okay. So this is all of the stuff that comes from that. So then I'm going to, like I said, I've already done some filtering with a Python program, but we'll use that to do the last of the filtering. So the Python program, I also have some flags that will go ahead and look at the visibility of this. And I've still got to finish that program a little bit. Let me see, it is AB2 AH2. So okay, so I'm just putting in a formula that I need that will 3, 4, 5, 6 that will determine whether that will tell me very quickly if the object is visible. Okay, and okay, so the ones are where it's visible in this column. Okay, that'll be something you might have to work on a little bit. Let me know if you have any trouble with that. I'll show you how to do it just using Las Cumbres. You're going to, like I said, you're going to want to filter this for magnitude and for transit depth. I'm just going to go ahead and filter it for this, for whether or not it's observable. And then I'm going to also order it by midpoint calendar. That's the midpoint of the transit. So we're going to do this. And so I highlight everything. I should tell you a little bit. I assume you're all familiar with spreadsheets, but I'll kind of show you just in case. So if you press on shift and then you move around with the arrows, it's sticky, and so it'll pick up all the cells. If I don't hold shift, it does this. So shift and the arrows. And then if I press control and press an arrow, it'll jump until like either the end of the data or the beginning of the data. So, okay, once I get here, I can press shift control down and it picks up all the way down. Okay. And then I'm going to sort this. And the window, of course, opens up on the other screen. I'm going to sort this by column AT, which this is this observability thing that I just created. Descending, so that'll put the ones first. And then sort it by column T, which is conveniently timed, so easy to remember. Okay. What you'll want to do first is you'll probably want to sort by magnitude or transit depth. And then anything that doesn't have a magnitude, that has a magnitude that's too faint or a transit depth that's too shallow to be realistic to observe, I would personally delete those. So let's come down to I would just go ahead, jump in there, scroll down. Remember that you'll have 35,000. I've shortened this list by a lot. And so then I can go ahead, delete rows, and then say, pretend I just filtered that by transit depth. You know, I get rid of all the ones that don't have a deep enough transit depth, make it easy to observe. And then maybe filter them by magnitude next and get rid of the ones. Is that making sense to everyone? Yes, no? Okay, and any questions so far?
Any questions?
Yeah.
Is it making sense? Or you guys ready to follow along? Or if you have any questions, you can ask.
Yeah, I promise not to bite.
Yes. You can ask out loud or you can type them in the chat.
For those interested,
It's so good to see all of you. I know some of you
All right.
just joined again, so welcome. And we are with our science host, JD Armstrong. Let's head back to you, JD. We'll take questions
Okay.
in the chat anytime, okay? Yes, thank you, JD.
Okay, great. Okay, so this is now sorted by whether or not this initial cut of visibility is looks like it's going to be visible. And then it's sorted by midpoint calendar. So the calendar date of the midpoint. I want to go down to, I've already been working with this list, so I want to go down to about the 30th of March. And I want to start here. I'm going to start on the 31st. And okay, I don't want to do a target of interest because of the project that this is for. So I'm just going to go ahead. This is my way of doing it. Find a way that works for you. And so I'm just going to mark this as gray so I know that, okay, I'm done with that. I don't want to use that. I've got a second spreadsheet that has, that basically just, I put the line in here and it grabs some things and does a few calculations for me to make it quick and easy to evaluate whether or not I want to do this. Okay. And so right now, first thing is I check is this observable? It says that probably is. This is not foolproof. You need brains, but hopefully we all have those. And then I double check the magnitude. So this is magnitude 9.37. That's plenty bright to get a good quality transit. And the transit depth, I put down here, 1.15% transit depth. That's fantastic. And so I basically just copy this transit depth from over here in the column where it says, and so forth. Okay. The start and stop times. You want to think a little bit about what you're doing. You're observing the transit, and it will tell you the duration, which is called T14. Now, this one, apparently it didn't have a transit duration. And so I'm probably using an estimate. So I use an estimate of the period of the orbital period in days, except for just convert it to hours. So it's an estimate. It usually works. It's usually close enough, but it's something to remember. You might want to give a little extra time on something like that. But the fact that it's not well known, sometimes those are the ones you want to get. So, go ahead and take a couple of risks with data. And if you really get desperate, you come back and ask me to take an observation or two with you. So I check on the duration then, we don't want it to start right at the beginning of the transit. You want to have sort of a short period before the transit starts and after the transit ends. And so I add 1 hour to the total duration. Okay. And then this is, so this will start half an hour before the midpoint minus half the duration. Boy, that was not the right way to explain that. So the formula I've got is, here's the midpoint. This is the time from first contact to last contact, how many hours the transit actually takes. And then I add 1 so that I get that level part. And then I divide by 48. So normally you would think, oh, well, you're converting this to days, from hours to days, because this is in days, in units of days. And so you would divide it by 24, but I also want to divide it by 2 because I want to take half the period and half an hour before the start of the transit, before the midpoint, to get when I want to start observations. Okay, did I explain that well enough for people following? How about giving a thumbs up if you're okay, or thumbs down if you would like to see a little better explanation?
I think, are those thumbs ups? I can't tell. Kirubal?
Is there any thumbs up? You guys?
Okay.
Yeah, okay. We've got a couple.
Okay,
All right.
good. Yes. Okay, so this just really quickly calculates the start and stop time for me. Organizes it so I can really quickly look at what I need, including down here, the right ascension declination. Not every exoplanet is really very easily observable. So let's go ahead and look at this exoplanet on a page called Simbad, Simbad. Okay. So if you go to Simbad, it always comes up the fictional character, or the character Simbad. But you can go into Simbad basic query, and notice that it is spelled different than Sinbad. So yes. And if you put a basic query, so HD 63454, that was the name of the exoplanet we're looking at. And this B, this lowercase b, or sometimes as a C, D, whatever, That specifies the exoplanet. So if I leave that off, it will give me information about the star, which is what we want. So I'm going to go ahead and search. Here we go. Okay, so I can double check my magnitudes here. These will be more reliable even than the NASA. So these are probably the best magnitudes you can find. Also, sometimes you'll get a RP filter, an RP magnitude, which is perfect because that's what I advise observing this with. And we also can come over here and we can look at the star. I'm going to zoom out with the scroll mouse, with the scroll wheel on my mouse. And okay, field of view, 14 arc minutes. So this is sort of comparable. Actually, no, this is still less than the field of view of what you'll get from the OM4 network. But basically, I just want to look, see, is there a good comparison star? Yeah, these will be good enough, but there's also this one that's even closer. There's not a lot of little other stars that'll make it hard. So if you're looking for an easy target, this is a good one. So what do you say we program this one in?
I say
Or
let's
at least try.
Yes, let's try for it. Yes.
Okay. So this is the Las Cumbres interface, the web interface that I imagine that you will have access to this. And we go up to, so from the Las Cumbres webpage for observers, observing portals, how do you get there? Submit observation. Okay, and this will open up the form. Okay, the name. This is the name of the observation request. I usually use the target, or at least have the target in the name of the observing request. So I'm going to go ahead and call it just what it is, or the target name. You might not have multiple accounts. I do, and so I'm going to use this account. This IPP factor, that's an interproposal priority factor. So 1 is basically the average priority for your account. If this is a lower priority observation, you might put a little bit lower priority in there so you can kind of bank some priority. And then if it's a really important one, you might bump this up a little bit, maybe go as high as 1.4. If you've got enough priority banked, you can do that. Usually with these, I just go with 1 so that I don't spend any, but I also don't get any. Okay. Don't worry about that too much if it's confusing. We're going to come down. So this acceptability threshold, probably not going to be very useful for exoplanets, but possibly some of the other things you do. So if the observations begin, but they don't have enough time to complete, then the request will be considered fulfilled if you've got 90% of the observations already taken. If not, then it's going to try to start again at a later time. Okay. I rarely mess with this. Configuration repeats. So this I use quite a bit. And maybe let's do that with this one. Well, maybe, basically you can have multiple configurations. So let's say I wanted to go observe with a green filter, then a red filter, and then a green filter, then a red filter, repeat until it's done. What you would do is you can have multiple instrument configurations with multiple filters. And then this basically says, go through all of these configurations and then do it again this many times. I'm going to leave it for 1 for right now. We'll figure out whether we want to do that or not. Okay. Observation type. The image is, of course, image. There are also spectrographs on the Las Cumbres network. And so we can look at that later if you're interested. And then you can choose your telescope class. I'm just going to use the 40 centimeter network, the OM4 network, because that's all I need for these observations. I never mess with this, so I don't know. Dither, you do not want to do that for exoplanet observations. What you can do is you can tell it, we want a dither pattern, which means it'll move around in a pattern. And that's useful for some other things, but not for photometry. You generally don't want it moving any more than you have to. The sub-exposure is a new thing. This was recently added, and I think it's using the reading out a small part of the chip for a guider. I have not yet used that sub-exposure. And so I just leave it blank. Exposure count, we will figure out later. Exposure time. So, oh, look, there's this wonderful exposure time calculator. I recommend this. Okay, 4 exoplanets. I'm just going to go ahead and grab the magnitude that NASA gave me, and that was confirmed by Sinbad. And where did okay. So I put the exposure, the magnitude in here. And for exoplanets, I recommend trying about a signal to noise of 300 to 400. You want to keep your peak data number below about 20,000 for these. Okay. And so that says integration time of 4 seconds. So we're going to go ahead and we're going to tell it 4 seconds. I usually go with a red filter. Red is usually the best filter for these telescopes to do exoplanet observations. The signal to noise is better, and the sensitivity is probably best in the red. And then we come down and select on target. Now, the telescope will probably recognize this target right off. So I put a target name in here, and it goes and it searches Sinbad, which is where we just were. And then it comes up with, here's the right ascension, here's the declination. Oh, cool. This is very far south. So I always like it when, being in the northern hemisphere, it kind of is neat to get a target from the south. It makes it seem cool to people. I double check the right ascension declination that I got from NASA. And yep, those are good. Okay, constraints, maximum air mass. This is basically how far down near the horizon you want to get. They suggest a maximum of 1.6. I would suggest that's usually a pretty good suggestion, but don't go below 2 unless you really need it. And you just realize you're kind of observing through a lot of air. So your observation quality will degrade. Minimum lunar separation in degrees. Okay. And then visibility. So this calculates when this is visible. Let me explain this chart because this is really cool. The different colored lines are different sites on the network. So for example, yellow is Siding Springs in Australia. The green is Sutherland Observatory in South Africa, and then Cerro Tololo in Chile. Up and down is the air mass. So if you're looking straight up, it's an air mass of 1, but this is quite a ways south, so we don't. So even at zenith, it's not going to be that low an air mass. So it gets up pretty good. And it looks like, and wherever there's a solid line, that shows that it is visible. And then on this graph, it does not put a line if it's up but not visible. So the reason these are starting where they're starting is this is the start of observations. Prior to that is twilight and then daytime. Okay. So where there's a solid line, that's good. You can observe there. Yes? Pardon?
Karubal, I'm sorry, we can't quite hear you. Can you put your question in the chat, please? Thank you so much.
Yeah.
Oh, I see. I see you're typing.
Okay.
We'll wait for your question.
There also is a target visibility calculator that I'll run to real quick. And so if we put this targeting in again, it should look it up, or you can type in the right ascension declination yourself. Okay. And then this daily visibility will show a very similar graph. Okay.
Oh,
this is altitude instead.
JD, the request is, can you make your screen full screen so we can see everything?
Am I not sharing full screen?
No, you're sharing full screen, but that's just part screen. If you could make that full.
Like, is that?
Go ahead and share again.
Okay. Is that better?
Let's see. Yes, exactly. And if you could zoom in just a little bit more so that everyone can see. Yeah, that's perfect.
There we go.
Yes.
Yeah. Okay. So there's that graph. Okay. And we'll come over here, zoom in here. Hopefully, yeah, there we go. That's as much as I can zoom in. So here's the graph on the observing portal. Okay, and all the different things we put in. So this is the visibility graph. And here's the graph from the visibility tool. Notice that up and down on this is the altitude in degrees. Okay. And then here's the air mass over here, but it's a little more intuitive until you get used to it. And you can specify telescope size if you want. So another very helpful tool. And we'll come back over here. There we go. So here's the magnitude that I got from the NASA site, signal noise 400. Peak data number, this is the largest number that it predicts in any pixel of the star, the brightest pixel in the star. And you don't want to go too bright because then you start overflowing and
can you hear? We might have lost power. We wait a little bit for the generator to kick back, and then we can continue.
Of course. Just let us know when to resume.
Yeah, in the meantime, I mean, if the students have any question, you can ask any question.
That's
any
right.
questions, anything you want to know from an astronomer.
Device is ready to pair. The Bluetooth device is connected successfully.
Okay, we have power.
Okay. All right. So we're ready to go. Everything up and running again?
Tiny bit moment.
Okay. Then we'll go one more request for a question from any of the students.
ጥያቄ ያላችሁ? እስካሁን ስለምን እንዳወራን ተረድታችኋል አይደል? መጀመሪያ ታርጌት ሰሌክት ማድረግ ነው። ከናሳ ዌብሳይት ላይ ሄዳችሁ ማለት ነው ለኤግዞፕላኔት ሰው የምትመርጡትን ታርጌት ቪዚቢሊቲ ኢን ተርምስ ኦፍ ማግኒቲዩድ ከዛ ላይ ዳታ ወስዳችሁ ነው የምትመርጡት። ከዛ ዳታ ከመረጣችሁ በኋላ ኤልሲኦ ላይ ገብታችሁ ለምን ያክል ሰዓት ነው የሚመለከተው የሚለውን ቫልዩ የምታገኙት ከሌላ ዌብሳይት ላይ ገብታችሁ ነው። ከዛ ነው ምስተላላችሁ። ስፔሲፊክ ጥያቄ ግን ካላችሁ ፕሊዝ ጠይቁ። ኦኬ Okay, I think you can continue.
Okay, great. So, okay, we talked about visibility quite extensively. You're probably tired of hearing that. So now what we need to do is we need to tell it when we need to define this window. The start time is the earliest it will begin the observations, and the end time is what the latest it will complete the observations. So all the observations have to fit in between the start and the end. And so we come over to this where I've calculated the start and end time. I'm just going to put this down on the other screen. And this is for the 31st of March. This will show up if you have like weird things like, hey, the start window can't be later than the end. That doesn't make sense. And cannot be the same time. So I'm going to just do that for the moment. Okay. So my calculations are that this should be observed from about 1:15 to 5:04. And that's in universal time. We always want to work in universal time. And on the 31st. So I'm going to actually go 15 minutes earlier than that. So I need another 15 minutes because you want to give the telescopes a little bit of leeway so that if they don't start at exactly the right time, it doesn't give up. Okay, so giving about 15 minutes to move around. And then we want to do about 15 minutes on the back end. So it's about 5:15. Okay. And let's see. Okay, the start is good, but the end is not so good. So we might come up here and change the air mass. But even with that air mass, we're not going to quite get to 5:15. So this is a case where I've been a little bit too generous on my program to filter. But a good example for what you'll probably end up doing. You'll go through several different ones. You might start off in the visibility tool to do this. Okay. So let's find one that we can observe that is a little bit easier to observe. Let's see here. Get the filtered list. So I'm going to just go ahead and mark that gray. I don't want to do targets of interest. KPS, I do want to do. Okay. This one is magnitude 12.97. So about magnitude 13. It's got a decent transit depth. And so I'm going to go ahead and look in Simbad again. Okay. So this is a star. Okay, this might not quite be what I want, but we're going to press forward. Okay. Yeah, and so again, we still don't have an R filter, so we'll just go, I'll use the green filter. And look around. Oh, this is a nice isolated star. This is a really good set to start with because you've got these two isolated stars. This can be used as a comparison star for the observations of that. So hopefully this one will work. looking for the right spreadsheet, and I'm going to slide this off. So really quickly, just change those two. The exposure time, let's see, was about 13 magnitude. So 87, we're going to call it 90 seconds. Maybe I should just be going with 87, then just 90 seconds will be close enough. Okay. And then the transit duration on this, T14 is 1.4 hours. That's good. So the predicted time that we want to start is about 4:43. Again, I'm going to take off another about 15 minutes. So let's go with 4:28 or 4:28. Am I doing my math right? Okay.
Or
So about
yeah,
43 minus 15, 28, right?
yeah. But you have it
Okay.
at 18.
Okay, thank you. Good. Yeah, see, this is why I keep Shamika around, is she reminds me when I'm absent-minded. Okay, so it goes from 4:28 until 7:04, so we'll call that 7:20. Okay. All right, the brown I know is McDonald Observatory in Texas. It's a good site, but I'm just so spoiled with outstanding sites that it's my least favorite site on the network. Sorry, guys, but it's still a really good site. It really is. Okay, so now we've got this set up. This one we can observe because it covers the whole span. Okay, we can zoom in a bit. And the graph is sometimes on this front end. It doesn't quite show it all the way to the time. It's actually being pretty good there. And then we can check the other end. And okay, yeah. So this is covering the full time. Notice that the graph doesn't quite make it to 720. It's just a quirk. And so everything's good. So this looks great. So 728 to 720, that's 2 hours and 8 minutes, or no, 2 hours and 52 minutes, right?
Just under 3 hours.
Just under 3 hours. Okay. So we've got just under 3 hours. We want to adjust this exposure count to get just under 3 hours. Oh, that was a lucky guess. Usually it doesn't work that well. And so you want maybe 10, 15 minutes short of your full time. Again, that's just to give the telescopes time in case they don't start right on the moment, so that they have a little bit of leeway. So we might want to go couple frames shorter than that. So 2 hours, 35 minutes. I'm pretty happy with that. And again, we're alternating between like a red and a green filter, you could copy this, make a green filter. You'd have one exposure count on both of these, and you would go to configuration repeats. Okay. Okay. So there we go. All right. I like this, and I'm going to submit this because this would be wonderful for the Teach Astro group. Okay. So fingers crossed that we get that. So let's look at downloading the data. It's actually pretty easy. I'm going to download this data because I need this. This is actually an asteroid, a near-Earth asteroid candidate, actually near-Earth object, probably a satellite. So once the observations have been completed, you'll see a green bar here. Okay, if you get a red bar, sometimes that means that they were partially completed. You can check, okay, this was never scheduled, so that didn't have any, but sometimes it only gets partway through, maybe the weather ends it. So downloading the data, you go to your observations, come over to data, and with Las Cumbres, they already do flat field bias and darks corrections for you. If you want those dark bias flats, you can get them. But usually we just go ahead and go with the reduced images. So with a small group like this, a small number of images like this, oh, this isn't as small as I thought. You could go, if it's only a few images, you could go ahead and click on the ones you want, check those, and then download selected. But with this many images, I'm going to want to go to View on Archive. Okay, and I want the reduced, with the reduction level is called Bonsai. And so reduction level Bonsai. Okay. So if I filter by reduction level, that'll just give me the reduced ones. And then you can change the number of exposures that you want. Okay. And so I'm going to go ahead and download these because I want to do my reduction on those and see if I got the target. So there we go. Okay, does that make sense how to download them?
Yes, we'll take questions about retrieving your data. Kirubo.
And remember, the people at Las Cumbres are awesome. Feel free to send them an email. My guess is you're probably working with Edward Gomez. Is that right? Maybe. Well, if it's Edward, he's just really great. He's a friend of mine. Feel free to ask him questions. He's really helpful.
Can you hear me?
Yes.
Great.
So,
If
okay.
you have a question you want to ask so far on the workflow, selecting your target to like knowing your setting that will input into the observatory portal. If you have any questions, no questions? All right, I think we can continue.
Okay.
Perhaps we can summarize it later on.
Yeah, I've got a little bit of a sheet that I put together that will hopefully act as a reminder for each step. And if you need me to come back and once you've got, some targets in mind, sometimes the best way to learn something is doing it. So we could meet again if that would be helpful. Or feel free to ask questions of Las Cumbres. They really are a great group of people. Okay. So really quickly, I'm going to show you what I genuinely use for the first pass at making a light curve, doing the measurements on these images. This is called AstroImage J. It's a piece of software that's free. It runs in Java, so it can be run on different platforms. So I don't care if you're a PC or a Mac user, you can use this. I think they might even have it for Linux. So when you open up the program, this is the AstroImage J interface. This is all you get. For a series of exoplanet images, you're going to want to click on File, Import an Image Sequence. Okay. I'm just going to go through this really quick. You're not going to be expected to remember this. It's just so you've seen it once. Okay. You can go ahead and click on Browse to go to whichever folder has the images you want. So let's go to Miscellaneous. I've already taken a look at these, but we'll take a look at them again. So these are some images of an exoplanet transit that I took for that same program. And so you click on that, you look in this folder, and it says, oh, there's nothing in this folder. Trust me, there is something in that folder. I will show you. So here we go. So it's got all these files in it, but it says there's nothing, it doesn't show any of them. So that is really confusing. But down here it says, oh, there are 55 items in this, 55 matched files. This is one of the quirks. It's kind of ways that are not intuitive. Okay. Once you have that folder selected, just tell it, okay, selected, then you can come back here. It says, okay, there's 1 to 55 items. That's good. That's what I expect. Click on OK. And then it loads in all of our images. And hopefully this is not the hard one that I was looking at. Okay. Yes, this is. Okay. I'm going to go to Simbad and try to figure out which star it is.
Now, this
So
is an
back,
asteroid observation, correct?
no, this is an exoplanet.
This is an exoplanet one. Okay.
Mm-hmm. So we're going to go back to Simbad. So this is the star that hosts the exoplanet. Oh yeah, this is it's a high proper motion star, which means it's moving fast enough in the sky that we're not going to see it quite where it's supposed to be. You see that one of the images in the survey was taken at a slightly different time and it moved during that time. So kind of be aware that, yeah, on this one, maybe you don't, you may or may not have these problems, but for this one, okay, so I think I found it. Should be close to the center of the image. Yeah, so I think that this is it. These two are this one. I'm not seeing that for some reason. I think that's the star. First thing you want to do is you want to do brain is not cooperating right now. So you want to click on one of the stars. I clicked on it, nothing happens, which is one of the weird things about this piece of software. We come up to Analyze, Plot Seeing Profile. That's the word I was trying for. And it'll give you a plot of the seeing profile. This is the center of the star. This is how bright it is. And then as farther away from the star, gets fainter. It'll then give you an idea of suggested values for your apertures. I'm going to go ahead and save those because they're usually good suggestions. Okay. Oh, now it shows up. Okay, so I want to sweep those. I'm going to perform multi-aperture photometry. That's the 2 circles. Click on that. This screen will open up. I copied and pasted this into that document that I made for you, so you can use exactly the same settings that I use. And hopefully you will learn how to use this better than I do at some point. And so you will go with your own settings. Okay. The one thing to note is these are the radii that we just set. Okay. Once you're happy with all these settings, and I'm going to have it use auto comparison stars. This is definitely, to begin with, this is the way to go. place apertures. Okay, and I'm going to click on my target, which I believe is this one. If not, I'm going to look foolish in a moment. Okay. And then it goes online and looks for good comparison stars in the image. Okay. If I wanted to choose my own comparison stars, I would just click on the next one and that adds a comparison star. When I'm done, I right click, and you can't see this yet, but like 50 different windows open up all over my computer.
We got
Device
power issues again.
successfully.
Give me a bit of a minute. We'll reconnect.
Okay.
again.
No problem. So this is a good time for questions from anyone. If you have questions
Yeah, I
about
mean,
what we've
if I were you
far.
guys, I would ask a lot of questions.
And
I think you guys seem to be getting it really good then, or
I hope so.
and that's great because I'm actually learning how to use Astro Image J. I'm doing research with JD and learning from him, and so I'm learning how to do this myself. And it has quirks. So if you're picking it up on the first time, that's great. But also you will have this recording to refer to, and I also have this data sheet that JD has made for you that I will send to Karubal and he can share it with everyone else that you can refer to. But we can also have follow-up sessions with him to go over these specific things, like once you have your data, how to do the analysis, and then specifically how to look at an object using your data from using your data with Astro Image J. We can definitely meet back up with JD. So don't feel stressed if you have further questions or if you need to process this a little bit more before you have questions.
okay.
Okay.
We can continue.
We can continue? All right.
Yes.
So let me back up. Okay, so it was just about the time a whole bunch of images appear. So I'm going to go back, hit the rewind button, and it's hiding Astro Image J on me. Okay, so we did file, import, image sequence. That'll be the same folder. Okay, load those up because I closed those. I didn't mean to. And we got 1 minute left. Hopefully we can run over a little bit. Okay.
Yes.
So, yeah, okay. So I think that's the target, and it turned out that I was correct. So we do multi-aperture photometry. Put all these settings in here. Auto comparison stars will give you comparison stars that are recommended. And so I always go with that. And then place apertures. Actually, I always go with that for exoplanets. Other things, not so much. And then I left click on the target. Comes up with a bunch of comparison stars. If it doesn't come up with any comparison stars, then you can click on stars to add them in. If you click off to the side a little bit, it'll kind of center it for you. So if you're not perfect on that placement with the mouse, it should be okay. Right click, whole bunch of windows show up. And here you go. We're watching the graph as it measures each image. And I think I hit the wrong star this time. So I'm going to close that. I got it right last time, honest.
Yeah, you definitely did.
Yeah, so, okay. Just going to reload this, import image sequence, browse. Oh no, don't browse because it's got the right folder. Okay. And let's get Sinbad back because we'll want that. Okay, so there we go. Zoom in. And yeah, see, this is a high proper motion star. I should have chosen an easier target.
So the star
Is
has
it this
shifted a
one?
little bit.
Yeah, it's moved. When you look at this images in Sinbad, the red image and the blue image were taken at different times by the survey, and the time was different enough that you actually see the star moving. To me, that's always kind of cool.
It is.
Yeah, so. And so let's try this one. Oh, place apertures. I think it's that one. We'll find out in just a moment.
And then right after this,
There
JD,
we go.
we have a question when you're ready.
Okay. So it'll put out a nice graph like this for you. You can actually change the title on the graph over here on the multi-plot main. It gets a little confusing for me about which window I want to be looking at to do various things. And so just kind of don't worry about it. Figure it out, play around with it. We can also plot the comparison stars. Okay, we can put those in there. And most importantly is this window here. Okay, it looks kind of like this, and then you make it larger. This is all of your data. I would save that, save as, and then put it somewhere convenient. Okay, so I've already, let's do it as this. New. Because I've also saved the transit graph. You can open that up in a notepad and drop it into LibreOffice. So, all right. So let's go ahead and go to the question because I'm running over, but I appreciate you joining. And so.
All right, excellent. Thank you so much, JD. All right, question. What are what are the strategies used to ensure data quality and like calibration and accessibility for both professional astronomers and non-expert users, such as students and educators?
One of the big things is get the exposure time right. So that exposure time calculator, I seriously use this. Where did it go? I seriously use this every time I'm doing exoplanet transits, and for each exoplanet, I will enter the magnitude and adjust it so that I know the quality. You don't want to overexpose because you can basically kind of blow out the image, so you're not really measuring how bright it is. It's just, oh, this is the maximum number that we can get from this pixel, and that's what we're seeing. And that loses information. If it's too faint, then you can't do the measurements. For some other things, so if you're using Las Cumbres, they do a lot of this stuff for you. A lot of the calibration images, like the flat fields, the biases, and the darks, they do it for you so that it's really, really easy. That's a but that is another thing that you need to worry about if you're using your own equipment, which is really cool if you do. It's a lot of fun. It's a lot of work, but it can be a lot of fun. Make sure you get good darks, biases, and flats. Astronomy is described as hurry up and wait. So you're rushing to get everything set up and get the telescope observing. And then while it's taking the images, you kind of just sit there and wait. And so, but make sure you get good darks, biases, and flats. Those are really helpful. I think most astronomers prefer sky flats. So after the sun sets and the sky's still kind of brightish, then taking your flat field exposures then. What else? Yeah, that's what's coming to top of my mind. Read the question again. Let me see if I.
Sure. What strategies are employed to ensure that data quality, calibration, and accessibility for both professional astronomers and non-expert users, such as students and educators? And I think you really spoke to that, but especially you said that the staff, the LCO staff, are very friendly and approachable. So
Yes, they are.
would they have like a support astronomer assigned to their citizen science project to assist them?
Yeah. Do you know the name of the person that you're working with, or do you have a contact at Las Cumbres that's helping you?
Yes. I
Oh,
think
do you know
his name is, I want to say Marcus, or
Marcus?
I'm guessing.
Yeah.
Hmm.
Okay.
Okay.
Let me see
Is
who
it
that
like-
is. I'll just jump. I used to go out to Santa Barbara about once a year for a meeting. And so I know a lot of these people. I'm not remembering Marcus right off. Let's look him up.
Martin. His name is Martin.
Is what?
Martin.
Oh, Martin.
Yeah.
Oh, yes.
Martin
Oh, yeah.
Dominic.
Martin Dominic. Okay, yeah. I think I know who he is. Let's education. Where's people? Here we go. Martin Dominic. I don't see him. Maybe okay. Well, anyway, I'm pretty sure I've met Martin, and really great. He's a really great guy. So yeah. I'm actually, am I in the past? Yeah, see here I am. Hey. Okay, so yeah, I'm considered an alumnus of Las Cumbres. I bet I still work with them a lot. All right. Any other questions?
Any other questions from the house? If not, I want to ask a question to the students. Early on, when you tried to look at the exoplanet transit, you said, "Oh no, I'm wrong," just by looking at the graph. And do the students know why he knew right away by looking at the graph he was wrong? Like he picked the wrong target?
Yeah, I picked the wrong star. Right.
And not the time duration, something you look at the graph. What do you expect on a graph of an exoplanet transit? A dip, right? A dip on the magnitude. So if you don't get that dip on the curve, you've selected the wrong target. Am I right?
Yes. Yeah, so let's go back here. And so I can kind of simulate that. So I can turn off the target. And so if I'd seen a graph like this, oh, well, there's no transit there. That's a Good observation. All right. Did everyone get that?
Is it clear? Okay, I think everyone got that.
Excellent.
Okay, good. Yeah.
So JD, if the students have questions afterwards, like I'm going to send a link to this edited recording, and after they watch it again, maybe and have a time to really listen to it in detail. If they have further questions, can I forward those to you?
Yeah, of course. Yes, it would be great to hear from you.
Okay. Awesome. Awesome. And JD has so kindly offered to do follow-up sessions with you all as well, especially once you get your you've chosen your targets. Can maybe go through this process using one of your actual targets and then come back and do some more work with you once you actually have some data. So in addition to Martin, you have a fantastic supporter here with JD. All right, JD, I know we've gone over 12 minutes. Karubal, anyone else? Any last questions or comments before we sign off?
All right, if you have any question, yeah, I see a hand. You can come closer to the mic so that they can hear you.
Yeah, come over and say hi, because I haven't seen any of you.
As well, so
Yeah.
you can come closer.
Okay. And we have another question in the chat to JD, which I'll ask after this person speaks.
Okay.
Okay.
I just want to ask if you have study guides or any prepared soft copies of this guide in soft copy. And
Yeah, let me show you. Let me show you what I've got. Yeah. This was like, I don't have much, but I did put together really quickly just kind of a notes of what I thought I was going to go over today. And let me load that up real quick so you can see. And Jamika will share this with you. And maybe what we should do is, if you would tell me what is missing, we can add that. If you have questions, kind of make this a living document. So just a really quick guide to find the targets I observed. I suggest using NASA Exoplanet Archive, program in the observations, couple things. For photometry of exoplanets, I typically use AstroImage-J. And like I said, I've got the screenshot from AstroImage-J of the multiple aperture photometry settings. And then once you guys get really good, if you're doing some exoplanet observations, NASA and the American Association of Variable Star Observers has a program called Exoplanet Watch. And you can process the data a different way using Exotic and submit to that program, which I would recommend. So, all right. So it's not much, but it's a beginning. And if you'll help me, we can make it as a team. We'll make it better.
Excellent.
Yeah,
And yes, in
all
the chat.
will be shared, like all the
Yes.
softwares and links we've used, websites. We will share them with you.
Mhm.
So
Yeah.
all the links that I share throughout the session, I will put them in this document also. I will share this with Krubel and work with Krubel to make sure everyone has access. And I see that some of you have sent me your email addresses. No problem. We'll make sure that you have access to the document. And I'll arrange with Krubel to maybe get all of your input in one place and then work with JD. We'll add it so that it can be a living document that's a really helpful resource for all of you. Okay, So we have a few more questions. So first is, what are the primary logistical and technical challenges in coordinating observations across such a geographically diverse array of instruments, and how are those challenges addressed, JD?
Okay, wow, it's a good thing that I've been behind the scenes at Las Cumbres. They actually make it seem pretty easy, and they really pull it off and make it seem easy. It's a very complicated challenge because I'm not the only scientist. We're not the only scientists that are entering observations into the network. So there are hundreds of people who are coming and doing this. And there's a challenge of building the schedule, and they rebuild it every few minutes based on, requests. And so everyone has a request. It has a request from all these different people. And then how do you allot the telescope time in order to best utilize the network? That's one of the biggest challenges. And yeah, and so there's actually something on Las Cumbres that kind of talks a little bit about that. That's kind of a fun thing. Is I know that Cyril's Cosmic Explorers, I think there were some things that it's had that talked about robotic telescopes and how the scheduler works. It's really a very impressive piece of software. So that's one of the main things. Then there's, the hardware of deploying these telescopes all around the world. Usually you have to have somebody from your headquarters go down at least a couple of times, and then hopefully you'll have an engineer that you can work with at these different sites that can do repairs and maintenance rather than sending people out. But yeah, getting the telescopes deployed was a lot of work too. And then just the engineering of building telescopes can be very complicated as well. So does that answer your question to your satisfaction?
Okay, excellent. Thank you. I saw nodding, and you can also, put anything else in the chat if you need a follow up. Okay, and so last we had, would you show us demonstrations, live demonstrations in our next session? And so yes, again, we're happy to have follow-up sessions with you, and I thank JD in advance for sharing his time. So yes, once you have a target list, then we can choose one target and go through this whole process with JD as a guide, and set up the observing request for your target. And we can do the same thing again once you get the data back, the image back. We can go through using Astro Image J. We didn't talk about DS9, did you this time, JD? No.
No, oh, that's right. DS9 is another wonderful piece of software. Again, free. It's available from Harvard Smithsonian. Let's make sure to get the link to that as well, because it's one of these pieces of software that I think every astronomer knows. Maybe I'm wrong, but I think everyone knows. And real quick, this is an example of what it looks like when one of the observations has made it onto the schedule. It gives the time right here. The observation that we just programmed in, however, does not have any scheduling information, so it's not made it onto a schedule yet. Okay. And so, yeah, a little bit of a preview of some of the realities of observing